The hidden math behind fairness. Fairness feels instinctive. We know it when we see it, and we feel its absence immediately. Yet the moment we try to define fairness, agreement dissolves. What seems obvious to one person feels deeply unjust to another. The conflict is not moral, it is mathematical. To understand why fairness matters today, we must slow down. Every system promises fairness. Laws, markets, schools, algorithms, but outcomes rarely feel fair. This gap creates anger, distrust, polarization. People sense imbalance, even when rules are followed perfectly. Something invisible is shaping results. Fairness is often treated as equality. Same rules, same inputs, same treatment. But identical treatment does not guarantee equal outcomes. And equal outcomes can feel deeply unfair. Mathematics noticed this problem early. Sharing problems expose it immediately. How do you divide fairly when needs differ? When resources are limited? When trade-offs are unavoidable? Simple splits fail quickly. 50% feels fair until context appears. One person needs more. Another contributed more. Another arrived later. This forced a deeper question. Is fairness about sameness? Proportionality? Opportunity? Outcome? Each answer creates a different system. Each system produces different winners. The moment rules are defined, fairness becomes measurable, and measurement introduces trade-offs. Optimizing one notion of fairness violates another. This is the hidden truth. Fairness is not a feeling. It is a choice between competing definitions. And every choice carries cost. Modern life is built on these choices. Taxes, voting, resource allocation, algorithms deciding visibility and access, all embed silent definitions of fairness. When outcomes feel wrong, it is often because the math disagrees with our intuition. The system did exactly what it was designed to do. The real mystery is not why fairness fails. It is why we expect it to be simple. Because once fairness is formalized, it stops being emotional and starts being structural. And that structure, quietly and relentlessly, shapes who benefits, who waits, and who is left behind. The conflict deepens when fairness meets scarcity. There is never enough for everyone. Time, money, attention, opportunity. Every system must choose how to allocate. Mathematics makes these choices explicit. Should resources be divided equally, or weighted by need, or rewarded by contribution? Each rule feels fair in isolation. Each feels unjust in practice. Consider cues. First come, first serve feels neutral, until some people arrive earlier by privilege. Random selection feels unbiased, until effort is ignored. Priority systems help the vulnerable, until others feel punished. No rule escapes trade-offs. Fairness becomes optimization under constraint. Improve one outcome, and another worsens. The math demands sacrifice. This is why fairness feels fragile. Small changes flip perceptions. A minor advantage compounds. Disparities grow quietly. What felt fair at the start feels rigged at the end. Algorithms expose this brutally. They follow rules precisely. Bias appears not from intent, but from data and objectives. Optimizing engagement reduces diversity. Optimizing efficiency reduces equity. Attempts to fix this create paradoxes. Equalizing outcomes restricts freedom. Maximizing choice increases inequality. Protecting groups reduces neutrality. Every correction breaks another promise. Mathematics names these limits. Impossibility theorems prove that certain fairness conditions cannot coexist. You must choose which to abandon. This realization is uncomfortable. People want perfect fairness. Math proves it cannot exist. Only compromises can. When systems fail, trust collapses. Not because rules were broken, but because expectations were impossible. Understanding this reframes conflict. Disagreements are not about morality alone. They are about incompatible definitions. People argue past each other, each defending a different fairness function. The danger lies in hiding these choices. When definitions are implicit, outcomes feel arbitrary. Power hides inside equations. Responsibility dissolves. Fairness is not found. It is designed. And design demands honesty about who pays the cost. This honesty is rare, but without it, systems fracture under resentment, because math does not disappear. It only operates unseen. This is where fairness becomes emotionally charged. When people realize trade-offs are unavoidable, someone must lose. Mathematics does not soften this truth. It exposes it. Every rule advantages one group, while disadvantaging another. Even neutrality produces unequal results. This creates moral tension. Those benefiting see fairness. Those excluded see bias. Both perspectives are mathematically valid. The system did exactly what was told. As inequality accumulates, feedback loops form, advantage compounds, access multiplies opportunity, disadvantage hardens into structure. Fair rules amplify unfair outcomes over time. Attempts to correct this face resistance. Interventions feel artificial. Merit feels diluted. Trust erodes. Fairness becomes politicized. Mathematics predicts this escalation. When outcomes diverge, perceptions polarize. Shared definitions fracture. Consensus collapses. This is why fairness debates feel endless. They are not about numbers. They are about which losses are acceptable, which values take priority, which trade-offs we tolerate. Systems that ignore this reality fail quietly. Resentment builds invisibly. Compliance fades. Legitimacy erodes. Eventually, rules lose meaning. Transparency changes the dynamic. When trade-offs are explicit, disagreement becomes possible. Negotiation replaces outrage. Responsibility becomes visible. This does not eliminate conflict. It makes it honest. People may still disagree, but they understand the cost. The deepest conflict is not unfairness. It is hidden unfairness. When math pretends neutrality while embedding choices, fairness survives only when its limits are acknowledged, when systems admit imperfection, when outcomes are monitored, not assumed, when revision is allowed. This transforms fairness from promise into process, not something achieved once, but something maintained continually. And this shift prepares the ground for a final realization. Fairness is not about eliminating conflict. It is about managing it without denial. The climax of fairness is not agreement. It is clarity. Once we accept that perfect fairness is impossible, the conversation changes. We stop searching for flawless systems. We start asking better questions. Which trade-offs are we making? Who benefits? Who pays the cost? And are we willing to revisit those choices? Mathematics does not remove morality. It forces it into the open. Every definition of fairness is a statement of values. Every rule encodes a priority. When systems acknowledge this, trust can return. Not because everyone wins, but because losses are no longer hidden. Honesty replaces illusion. Fairness becomes dynamic. Rules adapt. Outcomes are reviewed. Corrections are expected. The system stays alive. This is how resilient societies function. They argue openly about trade-offs. They revise structures without denial. They accept imperfection without surrendering responsibility. When fairness is treated as static, it fractures. When treated as process, it evolves. The hidden math was never the enemy. Silence was. Unspoken assumptions. Invisible priorities. Undefined costs. Once these are named, conflict becomes manageable, not painless, but productive. Fairness stops being a promise of equal outcomes. It becomes a commitment to transparent choice, to shared understanding, to continual adjustment. In a complex world, that may be the highest form of justice available. Not certainty, but accountability. Sometimes the smallest shift in perspective becomes the beginning of a new future. The hidden